The question is find the value of x for which the function y is equal to 100 upon x plus 4x reaches at its maximum. Okay, so we have the function y is equal to 100. Transpose this x to numerator, its exponent sign will change, it will become -1 plus 4x. We have this very function. Okay, first thing is we need to find out the first derivative of this function and set that equal to 0. So for first order condition for optimum is that the slope, that is dy upon dx, the slope of the function should be equal to 0. So let us take the derivative with respect to x. So the exponent of x becomes quotient, so we have -1 times 100 times x raised power exponent is subtracted by 1, okay, by power function rule, plus 4, the derivative of x is 1. Okay, we are applying power function rule. If we have x raised power n, its derivative will be n, exponent becomes quotient x, and exponent is subtracted by 1. Okay, here we have -1, so -1 became quotient, and we set it equal to 0. That gives us -100 times x raised power -2 plus 4 is equal to 0. Now solve it, so we'll get -100 divided by, transpose this to the denominator, exponent sign will change, is equal to, and transpose this 4 here, it becomes -4. Okay, multiplying both sides by -1, we will get rid of the negative sign from both sides. So we have 100 upon x square is equal to 4. Let us do the cross multiplication. That gives us 4x square is equal to 100, dividing both sides by 4, x square will be equal to 25, or x will be equal to plus minus under root 5. Okay, or x will be equal to either, rather we got plus minus under root 25, which is equal to 5 simply. So we will get x is equal to plus minus 5. That means we got the two values for the function where it where its slope is equal to 0. It is to say like this: if we have this kind of function, let us suppose, let me try to draw it clearly. So let us suppose this is our function. So we got 2 points where the function has slope equal to 0. One is x is equal to -5, and another is when x is equal to +5. Okay, now we need to check the second order condition for maximization, for maximum. So second order condition tells us we take the derivative of, that is, we take the second derivative, that is d square y upon dx square first. So let us find out. So this is the first derivative, its derivative gives us the second derivative. Again the exponent becomes quotient, so we have -2 times -100, and exponent is subtracted by 1, plus derivative of a constant is 0. So this is our second derivative, which is negative into negative is positive. We get 200 x raised power -3, or which is equal to 200 upon x cube. This is our second derivative. Okay, now we need to plug the critical values, x is equal to 5 and x is equal to -5, in the second derivative. If, or let me write it here. Now let's evaluate the second derivative at x is equal to -5. Now that means plug the value of x is equal to -5 in this equation. So what will we get? We have 200 divided by -5 cube, which will be equal to 200 divided by -125. So it will be a negative number, it will be negative number, and it will be less than 0. Okay, when the second derivative comes to be negative, when second derivative comes out to be negative, we get the maximum point. Okay, that means when x is equal to negative 5, this function gets us its maximum. Now if we evaluate it at x is equal to positive 5, so let us see d square y upon dx square, and evaluate it. This is our d square y upon dx square. So plug x is equal to 5, we will get here 200 divided by x cube is 5 cube, which is 125, which is greater than 0 here. Okay, if the second derivative comes out to be positive, then this satisfies the condition for minimum, since we need to find out the maximum point. So when the second derivative comes out to be negative, we get the condition for minimum. Okay, so the correct rather when x is equal to negative 5, this function reaches maximum, and it will look like this roughly. If I draw it like this, so it will look like this. So at x is equal to, let us say, negative 5, we reach the maximum. When x is equal to positive 5, the function reaches its minimum. Okay.